Hello Math 152 students. In this video we'll wrap up our 11.1 example. So we were ready to go to StatCrunch and compute our test statistic and p-value. So we want to just pull up a blank StatCrunch page, and very similar to chapter 10, we'll use the stat option, proportion stats, but we are in the two sample scenario. We have a summary, not the raw data. So this is where we want to enter our sample 1 and sample 2 information. So just go back and make sure that we don't mix anything up. I'm going to go back to our previous slide. This is our number of successes, our sample size, number of successes, sample size that we want to input. All right, so we had 338 successes out of 800 households for the urban, 292 out of 750 for our rural. And notice that StatCrunch gives it to us in this P1 minus P2 setup. So here, if we had formulated our hypothesis as P1 equals P2, we can just simply subtract our P2 over, make sure it matches this scenario. And in our hypothesis test for our null, when you have the P1 minus P2, you're always going to have equals 0 here. That's equivalent to the P1 equals P2. So we won't have a change here, but we do want to make a change. Our hypothesis for the alternative was that urban households had a greater percentage of internet access. That was the P1 is greater than P2. So if we were to move the P2 over, this is a P1 minus P2 is greater than 0. So just go back and check our scenario. This is exactly what we had in our setup, and we are ready to compute our p-value. Notice there's nothing else we really need to select. We don't need to see any of these additional plots. We're just ready to compute. So the most important piece of information from our display is our p-value. Our p-value is how we make our decision about our hypothesis test, but sometimes my math lab will also ask you for your test statistic. The test statistic is your z-stat. Here it's a test statistic for the P1 minus P2. So the interpretation of the 1.3 standard deviations above is a little trickier when we're looking at subtracting two proportions. But what we will focus on is this p-value. Notice this p-value of 0.092 is small, but we want to go back and compare to our alpha value to make sure it's small enough. So we've computed our p-value, and notice this p-value, I just put in a quick summary here. Our p-value is approximately 0.09, 0.092, and then we want to compare to our alpha level of 0.05. So we could say, since our p-value is greater than the level of significance, we fail to reject the null, or we can't reject the null. This also means that we can't accept the alternative. Kind of leaves us in that gray area of we don't have enough information to say, if we go back to our null and alternative, we don't have enough information to say the percentage is greater for urban households. But we really aren't saying that they're equal. We're saying we can't reject that they're equal, and we can't support the alternative. So let's figure out how we want to phrase this. One way to say it is there is insufficient evidence at the alpha equals 0.05 level to conclude that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So notice again, we're not saying we think the percentage is equal between the two. We're just saying we can't support the alternative and we can't rule out the null. So I like this phrasing. You just want to make sure the way you're phrasing it makes sense in the context of your problem. So to wrap up this example, let's just do a quick summary of our steps. If we go back to the very beginning, scroll through these slides, a lot of our work and the time that we spent was reading through the problem, understanding our setup, and checking our conditions. If your conditions don't check, you can't proceed. So this is a very important step. But once we got to our null and alternative setup, we were ready to have StatCrunch do the heavy lifting and produce our p-value for us. So this is pretty typical of what we'll see in Chapter 11. The problems themselves are longer to read through and digest. The setup is more complicated, but the actual computation and interpretation is pretty straightforward and similar to Chapter 10. So we'll stop here and pick up with examples of means in our next video.